then we have an oral test. So have we completed this silica part? Check it in your notes. GIANT covalent structure.
Silica.
Yes, this is a GIANT covalent structure. I told you diamond, silica, and graphite. Please open your notes and
yes, the last one we did was graphite.
The last one we did was graphite, right? This one we have already covered.
Yes, yes.
This part?
No.
Okay. So these are my properties of graphite. As I've already explained that your, what do we call as, your diamond, it is very hard. In fact, it is the hardest substance on earth. Okay. But graphite, it is soft and slippery. So these are very different properties, although both are made up from carbon. But in properties of graphite, you have to write that it is soft and slippery. This is your first property. Why it is soft and slippery? Because the sheet can slide over each other easily. Second property is that it is a good conductor of electricity. We have read in diamond that it is a poor conductor of electricity, but this is very opposite from diamond, that it is a good conductor of electricity. What makes graphite a good conductor of electricity? Because each carbon atom has 4 outer electrons, but it forms only 3 bonds in the graphite. So the 1 electron, that is 4th electron, it is free to move through the graphite carrying the charge. That's why this electron will carry the electricity. So you have to remember both these points for the graphite, that it is soft and slippery because the sheet can slide over each other easily, because you can see that there is a very neat structure of graphite. If you apply a force, then the sheets can easily slide. And it is a good conductor of electricity because, as I told you, that carbon can make 4 bonds. Okay, each carbon atom has 4 outer electrons, but in graphite only 3 are involved in bonding, and this 4th one is free. Okay, and that free electron is responsible for the conduction of electricity. Is it clear?
Yes, ma'am.
Write down the properties of graphite.
Okay.
So the next thing is the properties. Okay, it is a comparison of properties of diamond, graphite, and silica. So diamond is the hardest known substance. It does not conduct electricity. We have studied also. It sparkles when cut. Okay, you have seen the diamond jewelry, right? It sparkles when cut. Graphite, it is soft and slippery. It is soft and dark in color. Basically, the lead in your pencil, it is made up of graphite. So it is very soft and it is dark in color, black color. Okay. It conducts electricity because of the presence of free electron in it. Silica, it is hard and it can scratch the things. It is hard. Let's let light through it. The light gets passed through it, and it has a high melting point. Uses, you should also remember, diamond, it is used for drilling and cutting. For jewelry, it is used. Graphite, it is used as a lubricant, okay, for engines and locks. For pencil lead, it is also mixed with clay. For the electrodes and connecting brushes in generators. Silica, it is used in sandpaper. Sandpaper is a brown colored paper which is used in your chemistry laboratory for making glass and lenses, and in bricks for lining furnaces. So these are some properties and some uses of your GIANT covalent structures, that is diamond, graphite, and silica. Is it clear?
Yes, ma'am.
You have. Do you want to draw this table in your notebook?
Yes, please.
Okay. Okay. So this is your homework question. Take a screenshot of it. Question number 1 says that the covalent compound ethanol melts at minus 114 degrees Celsius. Is it a molecular compound or a GIANT structure? So I told you that GIANT structure have a high melting point, but molecular compound have low melting point. And the melting point is low, so it is a molecular compound. Okay. Question number 2, diamond and graphite are allotropes of carbon. What does that mean? Okay. Third question, why is diamond so hard? So you have to explain it on the basis of its structure and bonding. Done? Now let us differentiate between the molecular substances and the giant structures. So molecular substances have low melting points. That is because of the forces. The forces between the molecules are weak. That is why they have low melting point. And giant covalent structures such as sodium chloride and diamond, they have much higher melting point because the bonds between ions or atoms within giant structures are very strong. So you have to remember examples of molecular solids are carbon dioxide and water. Examples of giant ionic compounds are sodium chloride and magnesium oxide. They are giant ionic. Okay, we have studied that they are arranged as a three-dimensional lattice structure of alternating positive and negative ions. Giant covalent structure is your diamond, silica, and graphite. We have learned three giant covalent structures: diamond, silica, and graphite. And we have metals like iron and copper, which we'll study in the next slide about the metallic bonding. Okay, so write down these 2 points, the examples of the molecular, giant ionic, giant covalent, and the metal structure. You do not need to write down the melting point. You just need to remember that molecular substances have low melting point and giant structures have high melting points.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done?
Not yet. I'm almost done. I'm done.
Okay, next is the structure of metals. Okay. So in metals, the atoms are packed tightly together in a regular lattice, and this tight packing allows the outer electrons to separate from their atoms. So the metallic structure, it is a lattice of positive ions in a sea of electrons. Sea of electrons means there are many free electrons there which are free to move. So you can write down this line only, that in metallic bonding in metals, there is a lattice of positive ions in a sea of delocalized electrons. And there's a tight packing between the positive ions. So this allows your outer electrons to separate from their atoms. So that's why we can say that in metals, your atoms are tightly packed together in a regular lattice. That's why they have high melting point and high boiling point because of their tightly packing. For example, magnesium, sodium, they all are metals and they have high melting point. Is it clear?
Yeah.
Write down the structure of metals.
Mm, I'm done.
So you can see here, this is the example of copper metal, that we have copper 2+ ions, positive ions, which are arranged neatly, and these dots are my free electrons or delocalized electrons. So the copper ions, they are held together by their attraction to the free electrons between them, and these strong forces of attraction are called metallic bonds. The metallic bonds are the forces of attraction between the positive ions and these electrons. So what is a metallic bond? Metallic bond is the attraction between the metal ions and free electrons. What are your free electrons? What are your delocalized electrons? So the electrons that move freely in the metal lattice, they are not tied to any one ion. They are called delocalized electrons, which are responsible for the conduction of electricity. Okay, so write down the definition of metallic bond, the definition of delocalized electrons, and draw the metallic bonding in copper ion. Okay. Now, properties of metals. So in properties of metals, you have to write down that metals have high melting point, they are malleable and ductile. Malleable means that they can be hammered into different shapes. Ductile means they can be beaten into thin wires. Metals are good conductors of heat, good conductors of electricity. Why they are good conductors of heat? Because of the presence, why they are good conductors of electricity? Because of the presence of free electrons in them. Okay, the sea of delocalized electrons they have. So that's why they are good conductors of electricity. And why they are good conductors of heat? Because metals, they can easily move, the positive ions, electrons can easily move and transport your heat or energy throughout the material. So that's why they are good conductors of electricity. So these 4 points you have to remember: high melting point, malleable and ductile, good conductors of heat, and good conductors of electricity.